Hello there, welcome to October 2020 applied paper. Here we're looking at question 7. One end of a string is attached to a small ball P of mass 4m. The other end of the string is attached to another small ball Q of mass 3m. The string passes over a fixed pulley. Ball P is held at rest and with the string taut and the hanging parts of the string vertical as shown in figure 1. Ball P is released. The string is modelled as being light and inextensible, the balls are modelled as being particles, the pulley is modelled as being smooth and air resistance is ignored. Using the model, find in terms of M and G the magnitude of the force exerted on the pulley by the string while P is falling and Q hits the pulley. So what we're going to have here is we're going to have some tension at this point here, some tension where the pulley is attached to the roof, and given that the tensions will be here and here, because if you just imagine that we've got two particles either side here, there's going to be some tension in the string where the pulley is, and that's going to be T and T, actually equal values of T because it's one continuous piece of string. The point at which the pulley meets the roof, coming back to this point up here, is going to be 2T, just where the whole of these forces here are in equilibrium because the pulley system isn't actually moving, so forces should therefore be in equilibrium. So what we want to work out then is this value of 2T. But first of all we need to work out what T is equal to, and it might contain the values M and G in it, and that's fine. So what we'll do then is we'll do a few F equals ma equations on particles P and Q. So let's go ahead and do that. But let's first draw on our diagram what forces we have in play. For particle P we have an upwards force of tension. You can imagine at the point at which the string meets the particle, there's going to be some tension where the particle is drawing down or pulling down the string. So there's going to be some tension in that string at that point. And that tension will be equal to this tension up here. And there'll also be some tension pulling the particle down, and that will be the force of gravity. So that's going to be 4m times g, so 4mg there. On particle Q, there's going to be 3mg, that's the force of gravity, and then an upwards force of T as well, and that's the force where the string connects to the particle. So let's have a go at doing some Fa equals ma equations. Which direction is acceleration going to go in? Well, given that P is heavier, it's probably going to be going down at P and up at Q. So let's do P first. Let's do an F equals ma equation. So what are the forces acting on P? Well, we do positive force for if it's going downwards because acceleration is going downwards, and negative if the force is going upwards because acceleration is in the opposite direction then. So the force that we have going in the same direction as acceleration is 4mg. That's included as positive, and then we have T as another force, but acting in the opposite direction to acceleration, so that's going to be included as a minus T. So we've included all of our forces on the forces side of the equation. This is now going to be equal to the mass of the particle, which is 4m, times acceleration, which is a. Okay, so this is our F equals ma equation for particle P. We have 4mg as the force going downwards, the same direction as acceleration. We also have T as another force acting on P, acting upwards, so that's going to be the opposite direction to A, so it's included in our formula as minus T. And all of your forces must go on one side of the equation. On the other side of the equation goes mass and acceleration, so it's 4ma. Moving on to particle Q, this time upwards is positive, so T is going to be the letter that's going to be positive in this equation. So T is upwards, acceleration is upwards, so that's positive. And 3mg is a force pulling downwards when the acceleration is upwards, so that's going to be minus 3mg. Equals mass times acceleration, so that's 3ma. Now eventually what we want to do here is we want to work out what t is equal to. But at the moment, it might be more sensible to work out what a is equal to, because it's pretty easy if we add our equations together. If we add the equations together, we're going to get 4mg add minus 3mg, so that will just cancel out to a single 1mg. T and minus t will add together to make 0, so that will cancel out. And then 4ma and 3ma will cancel out to make 7ma. Cancel out your m's on both sides and divide by 7, we get 1/7 g as our value for the acceleration. So now what we can do is potentially work out what t is equal to. If we use equation q, then it's going to be t equals, I'm going to move this 3mg onto the other side, so it's going to be 3ma, so that's going to be 3m times the 7th g, so 3/7 mg, and then this 3mg that's added onto the other side, so that's going to be add 3mg. So therefore, the value of tension is going to be 21/7, 24/7 mg. But the total force exerted on the pulley, so the total force on pulley is 2 lots of this. So it's going to be 48/7 mg. 2 lots of the tension, because you can see either down here you have 2 lots of tension, so that's the force exerted on the pulley, or on the top here that's pointing upwards, in that's the anchor attaching the pulley system to the roof. That's also going to have a tension of 2t as well. So whichever way you look at it, the tension is 48/7 mg. So there we are, that's our answer to part A. Quite a long one there, but it was worth 8 marks, and I'm happy with that working for 8 marks. Moving on to part B, state one limitation of the model apart from ignoring air resistance that will affect the accuracy of your answer to part A. Well, we've got a number of different answers here. We've got the weight of the rope, the extensibility of the rope, and the pulley system may not be smooth. There may be friction on the pulley system. Any one of those answers is a good answer to answer part B with. So there we are, that's our answer for question 7. That's worth 9 marks in total. Let's move on to question 8.